All right, folks, if you stuck around our channel for very long, you know some of the things that I hope we see in the near future. Lights on the moon from civilization and more places for us to live and work in space. And so for today, we have a very special show for you. It's not just a show, we've got a guest. We're going to be doing some live Q&A with Max Haot from VAST, who are making commercial space stations. Not just rendering commercial space stations, actually testing stations now, getting ready to launch equipment. So stand by because it's time for a very special NSF Live. I'm John Galloway. Let's get into how we can deploy commercial space stations.
And here we go. We have liftoff. Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Downside FTE off. Bring in FTE off. It's orange! Orange 45! Oh my god! Oh my god! Decollage! Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
If methane would be igniting in the flare, correct?
We don't need any more of these.
All right, so like I said, this is a very special show, and there was actually some homework before this show. We actually got to go on, I don't want to say exclusive tour. VAST has given lots of people information on what they're doing, but we went on a tour of their factory out in California. So there's a video, a 70-plus minute video that if you are a member of the channel or you're a viewer of the channel, you may have already watched. And if you had questions during that video, this is your chance. You ever done that on YouTube where you're like, oh, I'm going to watch this video and then I'm done watching the video? Maybe you post a comment, maybe you're done with it. Here you have a special opportunity to watch that tour, all the stuff that we walked through, looking at hatches and valves and micro meteorite shields and all the stuff that Max showed us. And today, we've got Max live on the show to do some Q&A with us. So I've already gone through a bunch of the comments that were in that video and picked out some really good, really recurring questions. If you've got additional questions, maybe you didn't leave in the comments, tag us in chat at NASASpaceflight. It's going to put your question into a little queue over here, and we will get Max over to answer some questions. If you haven't seen this video yet, make sure you check out down in the description. There is a link to it. Stick with the live show for now, but don't miss the entire interview. It was so difficult to cut out interesting things because the entire interview was interesting. But let's go ahead and get on with the show here. Y'all didn't come to hear me talk. Max Haot, CEO of VAST. How are you doing, Max?
I'm great. Super excited to speak to your awesome audience. Thanks for inviting me. And I'm personally, a fan of the show and the forums, and have been for many years. So really happy to be here. So.
Good deal. And thank you for taking time with us this evening. I mean, it's afternoon, after hours over on the West Coast. You're in California, right?
Yeah, 5 p.m. I don't think it's after hours for VAST, but yeah, sure.
I like it. Good answer. I've got a green screen behind me, but I don't think that's a green screen behind you, is it?
No, this is actually what will be our clean room for final integration of Haven 1. And about a month ago, we finished building the qualification article, the primary structure that you might have seen or shown in our test stand in Mojave. So that really shipped out from here. And behind me is actually the line where we weld the flight unit. Right now, you have a piece of aluminum on the circular welder. It's a plasma welder. That's a development weld article right now. But last week, we did exactly here our first flight weld. And in the new updated timeline of Haven 1, you will see us completing the flight weldment by the end of June for July to start integration right in this room. So when we'll do integration, we'll actually move all this equipment into a new home for our primary structure welding area, which we have in another building. And this will get an epoxy white floor, and it's already a clean room with the filters above me. And this is actually where, for 6 months, we will be doing final integration of Haven 1 between July and the end of December this year.
Good deal. This is a comment from chat. One of the first comments that came through is that it looks like VAST is the real deal. And you're not in a conference room somewhere with a rendering behind you or something like that. You already had your qualification article that used to be right there behind you that has already went to Mojave and already passed a lot of the testing that it needs to do. And you're right back in there with another, you said development weld, right?
Yeah, and I wish I was in Mojave in front of the qual article. That would be cool, but it's a little windy there. So.
It's a little windy, bit of a drive, huh?
And outside, yeah, but it's fun. That would have been a cooler background, but next to it, I think this one is pretty awesome too. So.
I think as far as we've gone, this is one of the cooler backgrounds we've had on a guest on the show here, Max. So thank you and your team so much for taking the time to get set up there. But let's kick it off with that. When we visited you in December, you were there in front of the qualification article, right? It was in the room there behind you, there on the video. You can see us looking around. How's qualification testing going?
Yeah, so we performed after you left and after you issued the video. We performed the proof qualification test. So we pressurized Haven 1, the primary structure. And it's not just a primary structure, it also includes the actual hatch and the window and also the closeout hatch at the top. And so we pressurized it to 1.8 D-bar, basically, and we proved that it with our strain gauges and all of the sensors and that measurement we made, we proved that it met the requirement, which is really driven by NASA standard use in commercial crews and other historical space station.
Yep.
And then we passed that successfully on the first try. That was very exciting for the team. In the first time we ever did that, right, as a company, had a fully assembled qualification primary structure. And then over that weekend, we also left it pressurized at a lower pressure, and we calculated the leak rate. We could not even detect it, so we're very happy with that, and certainly met the requirements that we had to pass. Since then, we are right now started to perform and are preparing for different test cases that includes not only pressure, but also applying forces on the primary structure that are due to emulate some of the force that the Haven 1 will experience on ascent during launch. And so these tests are ongoing, going great. And they will probably still be going on for the next few weeks, but they're not critical path. Actually, our team back in Long Beach, since shipping out the Haven 1 qualification article, have been focused on starting to weld the actual flight primary structure. And obviously that started months ago with closing out the design, starting to machine panels, rolling them. And as I mentioned last week, we had our first vertical weld for one of the segment of Haven 1.
Gotcha. It's actually a really interesting question sort of flashing by here. You mentioned part of the qual testing is pressurizing it to levels that it would need to sustain during launch. During launch, is it pressurized to help maintain the structure, or is it, how do you launch it? Does it stay pressurized the entire time, I guess?
It's pressurized to help structurally, right?
Yep.
But also, it's a lot of nitrox that you would need to pressurize it later on orbit, and also, the whole interior, nothing is designed for being exposed to vacuum or for different pressure that you could have on ascent. So yes, it's pressurized, actually slightly over the nominal pressure, and then we plan to vent once we get to orbit some of that pressure.
Gotcha. So we hear that a lot, y'all, where a vehicle will be pressurized while they move it around or whatever. Sometimes that's on the ground. Clearly it needs to be in space, right? But here during launch, they'll keep the single shot sort of vast Haven 1 station pressurized during launch. We are going to be going through questions here. We are going to try to keep them a little bit relevant to the current topic we're talking about. So let's talk a little bit more about Haven 1, and then we're going to get into some of the specific questions on Haven 2. Sound good, Max?
Yeah, great.
All right, good deal. So qualification testing, it's the first time y'all have gone through, sort of following along with everything that y'all are doing. You built a lot of your own test stands out in Mojave to run all this testing. It's sort of your theme, like from the tour where you do all of the things yourself. You're not going to ship it off for 6 months so somebody else test it, bring it back, do this, bring it back, you know what I mean? It's all sort of in-house that you're doing this. But it's your team's first time to do a big test like that. How did it go for the team out there in Mojave?
I mean, what was great is that it was our first, vehicle ops. One of the many hundreds or thousands we will have as a company.
Yep.
And one of the best part of VAST is really the team and the culture we have and the experience they have. So many people, even for a test like this, have been on console with many popular program, crewed program or rocket program.
Yep.
And have obviously run many vehicle ops. So it was awesome for me to see how Haven One, a big part of Haven One is to go from 0 to 1 as a company and to make us become an actual space station company. My personal and our view is that unless you have a space station on orbit that has been visited by a crew that came back home safely, you are not a space station company. So by this standard, VAST is not yet a space station company, and neither any of our competitors. And so to start to see all of these team and this workflow and procedure in the residual experience we have in our team. For example, they've never done it together with exactly that team at that company and that culture with that procedure. To see it happen for the first time was really, really great.
Yeah.
And it was really good. It went super smooth, and we did it on the first try.
I think that's a lot of people don't understand. They think, oh, you design a space station and then you build it and then it's good, right? But so much of it is or are the teams and the people behind it gaining the experience how to step through your production processes, your test processes, or your launch or operations process. It's not just about making a really cool CAD file that the machine then makes and people put together. There are processes and experience you need to build as well, and it sounds like y'all are doing that.
Yeah, and if you look at the essence of VAST, of course, Haven 1 is a product of first space station. Haven 2 is our proposed plan to succeed the ISS. But the real essence of VAST is a company that can build safe, low-cost, at high speed crewed system, right? Not satellite, system that have humans involved.
Yep.
And if you start to think about how many companies have these qualities out there, I right now only know of one. If you combine obviously the low cost and the speed, and we have the chance and the window to become another one, right? That is qualified to do that. And Haven 1 is really when the Haven 1 crewed mission will occur and when everybody will be back home safe, is really the day we will earn this quality, which we're striving to get, but we don't have yet, right?
Yeah.
And so that's the essence of VAST if you think about it, and how people should see us.
It's a funny story. Like we talk to a lot of companies, Max, and a lot of times people will invite us to come. Oh yeah, come to our facility. And we only have so much time in the day. So one of the first questions I ask is, do you have hardware for us to see? Like, we don't just want to come and see your big CNC machine, but there's no actual space station hardware. Come and see these fantastic renders you have or anything like that. And right out of the gate, your team that we were working with to set up that original tour was like, yeah, of course we have hardware. And it echoes exactly what you're saying there. You want to be a space station company, but you need to have a space station in orbit. You don't want to be a space station idea company or a space station render company, right? So that was literally one of the gates. Like, do you have hardware we can actually come and see? And y'all's answer was yes. So we came out there and saw you.
Yeah, the good news is that every day it becomes easier, right? A year ago, that question, yes, we had hardware, but we had less, right? And,
yep.
And in a year, or we will have definitely a lot more. We'll have a fully built space station. But that's one of the exciting things, is that it's our culture that we are building in public, and the whole reason we are building Haven 1 is to build the confidence of our customers, which are either global space agencies, private individual,
yep.
but also NASA, which is not yet a customer. And really the CLD competition, the replacement to the ISS, is our chance to have them as a customer. Haven 1 is all about building that trust, right? And the way you build that trust is by putting yourself out there, by sharing the timeline transparently, by stating what you plan to do, by showing hardware, and then people can measure you. If you have delay, you have delay. If you so that's really our culture, and so that's why we welcome it, because it's the whole purpose is to build trust.
Yep.
And there's nothing like hardware on orbit with humans in it. That's the real everything else is the build up to that. So we just can't wait to get there. But every day is getting easier, because every day we have more hardware, more teams, more facilities to demonstrate.
Yeah, I really do think that it built up a lot of credibility. When we did the tour, we put the video out there, seeing the hardware, seeing the equipment you have, seeing that you're actually doing things. You're not just talking about the things you're going to do, you're actually doing them. You walked us through a space that was still being built, right? The mission control was under construction, and you're like, yeah, here's mission control, and here's a qual article right next to each other. Just, it builds credibility when you let people see stuff like that. I do want to check in real quick with some of the questions that we have going on over here. D, our cinematographer that was along with us for the tour, I think we've got D here with us, don't we, right now?
Yeah.
You on comms, D?
I sure am, and there are a lot of questions coming in from the chat right now. I think a great place to start off is one from Dylan Spicer. What kinds of experiments will commercial crews be doing on Haven 1?
So, a space station really has two key reasons to exist. One of them is to be a way to develop space exploration technologies and to train crew as you might go on to the moon and to Mars. So that's a key category of why you should have a space station, right? Like you might be developing a life support system, you might be testing a suit, you might be training an astronaut in low Earth orbit before they go onto the moon or Mars. The other category is that a space station is a microgravity laboratory in space, and obviously performing manufacturing process and experiment, whether it's material science, material development, or pharmaceutical development, and other type of manufacturing process, semiconductor, for example, manufacturing and so on, that could benefit from microgravity. That's the other reason to have a space station. So as part of Haven 1, we have created a facility called Haven 1 Lab, where we've carved out power in space. We have 10 mid-deck lockers, which is the format that actually came from the space shuttle and is now used for science and experiment racks on the ISS. And our strategy is to work with companies that have already done work on the ISS, so have already worked with pharmaceutical companies and so on, and brought their hardware on the ISS. The first two we announced is Redwire and another one in Europe called Yuri. And both of them are doing protein growth and crystallization type experiment, mainly aimed at the pharmaceutical industry. So these are the first two, but we will have others. I'm hoping we will have plants and that type of science there, and living plants, and we will announce these. We have 8 more mid-deck locker available that we have undisclosed partner and exciting science that our crew will be able to perform.
That's awesome.
Good deal.
So I do have one more question. You mentioned how low Earth orbit is one step to the moon and Mars, and Damien is wondering if in your roadmap at any point you have potential plans for a lunar space station, anything beyond low Earth orbit?
I mean, the way to think about it is back to the description I shared about how we see VAST. So we see VAST as a crewed system company that's safe, low cost, and super fast, which is how you also are low cost. And as you know, our roadmap has low Earth orbit space station, and also the ambition to be the first company to create an artificial gravity space station. But as you can imagine, we might have ambitions beyond that involves habitats, on some celestial bodies and planet. But more on that in the future.
I like it. Good deal. Hey, Max, can we jump in? There's a couple technical questions about Haven 1, like how solar panels work. Can we ask a couple technical questions?
Yeah, well, I'll try to answer them. I don't have my whole engineering team there to back me up, but let's give it a shot.
We see the renders of Haven 1, and the solar panels are sort of flat out the side. Are those solar panels going to be designed to track the sun, or are you going to leave the entire space station pointed towards the sun? How do you keep in those solar panels efficient?
So related to Haven 1, the root of the design of Haven 1 is we said, okay, we need, it's back in May 2023, and we said, okay, we need to win the NASA competition to replace the ISS. We need to become a space station company, right, back to my point. And we basically had two priorities. It needs to be safe, and number two priority needs to happen fast.
Yep.
And so the way to do that is to keep everything as simple as we can. Now, nothing is simple in the space station, but you want it to be relatively simple.
Right.
One of the key early decisions, there's a few simple decisions that, let's do one module, not multi-module, right? That's pretty obvious that you should start with that. And let's launch it on a vehicle that exists today that we know will be ready when we are.
Yep.
So that's Falcon 9 reusable single module. That's what Haven 1 is designed to do. The next decision we made is let's keep the lifetime to 3 years. Typically space station, you might try 10 years, 20 years. That pushed the propellant budget, that pushed the power budget with degradation in solar cells. And so we decided to, let's aim at 3 years on orbit, and then we deorbit it ourselves. And then the third decision we made is also to keep the life support system as simple as we can and rely on Dragon as much as we can.
Yep.
And it's an open loop type life support system, you could call it, right? We're not recycling water, oxygen, and we use pretty simple CO2 scrubbing LiO cartridge like the space shuttle used to use. I think Apollo used to use that, and Dragon use that today.
Right.
So when it came to solar, we decided to also keep it simple. So they are Z-fold, a solar array from a partner company in Spain called DHV. We've shared that.
Yep.
And they are fixed. So the answer to your question is we actually are changing the attitude of Haven 1 and sun pointing Haven 1, and actually Dragon also when Dragon is there. And we're tracking the sun at a given attitude, depending on whether in high beta and low beta, we fly in different ways.
Yep.
But the point is that they are not steerable, and we are pointing them in the sun attitude that we've designed it to.
Yep.
The other piece related to that is thermal management. You'll see that on the body of the shaded side of Haven 1, where we have the window, we also have radiators. And that's the other side, obviously, of power generation that is part of keeping it simple. We don't have deployable radiators. We have body-mounted radiators.
Folks, pay attention real quick, right? Because we ask a question, Max could have just been like, "Oh yeah, well no, they don't fold," but you get the entire reasoning behind why they sort of got to that decision. Why did they decide to keep it simple for the first one and do more complicated things in the future? Max, thank you so much. It's not just like, oh yeah, no, they're fixed. Just the reasoning behind everything really helps people get context. Apparently, is this unfolding?
You have the video just right there.
Yeah, Kevin's on the ball.
So there you go.
So through this, the entire space station will maintain an orientation so that it's sort of sun pointing and the panels are oriented in an optimal way when they need it to be, right?
Yes, that's the point. Yeah.
Makes good sense. All right. Same thing with the window. If I understood what you just said, the big dome, right, will be on the shaded side, not pointing towards the sun, but the entire station is sort of oriented in such a way so that the panels are here, and they want this way pointed at the sun. In the leeward, I guess the shaded side, away from the sun, is where the window is, correct?
Yeah, the cold side, and one of the other benefits in the way we fly is that that's also where you can see the Earth the most of the time. And one of the we traded different window position. Obviously, if you put it in the sun, you get some real thermal concern.
Yep.
So this is a good position for it. It also happens to be, with the attitude we're flying, a great view of the Earth. But we also have the option, we have propulsion, and we can, for a little while, do maneuvers and show the crew, a specific event that maybe might not be visible in the default flying configuration. So these are things we'll get into when we design the mission with our crew, and we're obviously not going to improvise it, last minute. But,
sure.
But you can imagine that maybe we will be doing some attitude change for Earth observation purpose for the crew.
Gotcha. And even that, Kevin, if we could get that other render that had the visiting capsule on it, if you're a fan of visiting capsules, you're a fan of a Dragon capsule, right? You know that the Dragon has sort of solar on one side of it, and the other side is not solar, right? Sort of built into the, I guess you could say built into the skin. But even in the rendering, the station arrays and the way that Dragon docks to the station also is designed to keep the Dragon's solar panels exposed towards the sun. Is that render, am I overanalyzing things, or is that render?
No, that's a key element of the, of the trades we did and the way we have designed it to keep it simple. As I mentioned, so the when Dragon gets to the ISS, it goes into question mode, so in sleep mode, and most systems are inactive. And for example, whether they want to, the crew wants to use the bathroom, the commode, or the crew is relying on CO2 scrubbing, at the moment the hatch is open, it's docked, it's sort of all transferred to the ISS. In our case, when we designed Haven 1, we said, hey, why don't we use as much of the capabilities of Dragon as SpaceX will let us do, right? Rely, divide, and conquer. And so we started to go through the list of all of the life support systems that Dragon have and see how much would be adequate to use for Haven 1 and Dragon together. So one of the key ones is, for example, the CO2 scrubbing. There is a mechanism in Dragon that the crew, whether it's on free flyer, on the way to the ISS, the crew basically every day has to put a LiO cartridge to scrub the CO2. And we decided to basically leverage, with this, obviously the agreement of SpaceX, to leverage their mechanism, but they are actually providing us 40 CO2 cartridge. They're pretty big and massive. I wish I had one with me here. We have some here. And we didn't show it to you on the tour, but they are launching with Haven 1. They're part of the Haven 1 14-ton mass budget and part of the volume. But then the crew has the ability to every day take it from Haven 1 and put it in Dragon. So that's one of the examples that why we need Dragon to be powered in order to do that. We also are leveraging the commode or the urine and solid stool bathroom of SpaceX. We don't have our own one in Haven 1. We are using the humidity removal mechanism and system. And then we have a big IMV duct, like a airflow in between Haven 1 and Dragon to make sure the air fully circulates with fans in between, and so that their mechanism can scrub the CO2 that's generated as well on Haven 1. So all of these reasons, and obviously we also get the benefit to have, they have a window on Dragon. They have extra volume, right? It's a lot of additional space that the crew can use. And we mentioned the closed bathroom there. And they also have backup communication for us and things like that. So it's like it brings us some redundancy to keep them fully active too.
It makes such good sense because your goal is not to design on the first shot the space station that will be used forever. Your goal is to take steps forward and to build technologies and to build. But why build a new technology if you don't have to for that first step? Reutilizing, that's not even a word, I just made that word up, Max. Reusing the existing scrubbers that are on board the Dragon and just carrying more consumables to plug into the Dragon system helps you get your idea, I was going to say to market, but actually it's space faster, right?
But the key, it's such a big leap to not be a space station company to become one. That like the simpler you can be, like that's why you have to prove that you can build that safe system and process and operate it in space and work with SpaceX. That's what we have to prove to NASA and our customers. The diameter of the space station, the exact features it will have, even the scale. These are sort of they're not details, but you can iterate your way to it once you've proven the baseline. So the more complicated you make the baseline, the least likely you are to succeed or the longer it will take. And that's one of the keys. So back to your point on the CO2 scrubber, in Haven 2 Module 1, our goal is to move the bathroom and the CO2 scrubbing mechanism inside the module. Guess what? If we're not ready by then, we can still do the same as we did for Haven 1 and still fly the module, and then we'll delay that to Module 2, right? So we really have a roadmap that allows us to cut in with iteration and improvement. And at the end of it, we need a more efficient, a closed loop, life support system that's on par in efficiency to the ISS.
Sure.
And our view is that, that's what we've said to NASA. We're very open about it. NASA should not be asking for that on day one of their CLD station, because all that will do is it will just delay when that first capability will come.
Yep.
NASA should allow it to start with something simple, like an upgraded Haven 1, and then the partners should upgrade it as soon as it can, adding modules and adding life support, more complicated life support capabilities.
Yeah. I mean, how many times do we, as, let's say, space enthusiasts, hear about, oh, the entire project is delayed because of this one little system? And you've already thought through that, and you've got these things sort of baked in where, hey, I'm not going to say my entire thing needs to be 3 years later because this one system we're waiting on. You have some opportunities where you can sort of step over things like that and delay this decision, that decision to a future sort of iteration, right? Do you consider this rapid iteration? Is this different for you? How does that sort of fall? Because we all love talking about rapid iteration these days.
I mean, I think it's a basic way of thinking to start with the simplest it can be that's useful. I mean, it's an approach that exists in software. You've seen also many successful aerospace companies do it, but that's really where it comes from. I don't think it's new, but we are applying it with a lot of discipline, I think, and it's having working.
Good deal. It's one of the reasons you've already got stuff out there. Qual testing, you have this entire roadmap. Let's see if we can't grab in some other questions here. Dee, do we have a couple audience questions you could grab?
Yes, we have a couple here. This first one from Steven, he's wondering what the critical factors are to let Haven 1 hit its net launch date next year.
Like the long pole to get ready.
We've put out a table of all the key milestones, and it's part of our our posture to be transparent, to be accountable there. So the big milestone you should look for is for us to have completed building and welding the flight primary structure, and sort of declare that we are starting integration, and that's scheduled for July. So if that's delayed, we are delayed. So you can keep an eye on that. And then we have a pretty intense 6-month-ish integration schedule. And so during that time, obviously, a lot of all of the subsystems have to be ready on time, and our integration has to proceed as planned. It's it's definitely a lot of phase of integration, a lot of work that is not a walk in the park, but we believe we have a shot at doing. And then the big one will be the testing at the NASA facility that people call Plumbrook. I think it's at the Glenn Center. This is the only facility that's big enough to put the whole of Haven 1 on a shaker table as a whole assembly. Obviously, we shake and we do thermal tests on all the sub-assemblies here. But then we will have the first opportunity to do vibration testing on the full Haven 1 integrated, and then also a thermal vacuum test in one of their amazing, unique in the world chamber that can accommodate Haven 1, and also some EMI testing. And that will be in Q1 next year. And of course, that has to go well, right? If we have some issue that are showstopper to fly, we might have to rework them, or at the launch site, or even bring it back to Long Beach. That would be a big hit on the timeline.
Right.
And then we plan to ship it right from there to the Cape for a 2-month launch campaign, filling propellant, finishing any item that needs to occur at the launch site, and obviously launch on a Falcon 9 reusable in early May. So that's the schedule. It's out there. We've put a blog post about a couple of weeks or 3 weeks ago, and people can check it out on vastspace.com. And if we have major deviations or setback from that, we're naturally going to have to update it.
Sure.
Because we're being transparent, and it's going to be obvious.
Yeah, that's how it works. But there's so many good questions coming in, y'all. I do want to get through as many as we can, but also we still have other things like Haven 2 to talk about. Max, one more thing, and this is straight from the video comments that we actually put out quite a few shorts too, talking about the trash on the station. And we had the vacuum trash can, right, where the wet trash is put and then exposed to the vacuum of space. And there was some confusion because a lot of people out there know the way the ISS works. And you have visiting vehicles, they go up, trash is generated, and sometimes the trash is put inside, say, a Cygnus cargo vehicle, and then it burns up in the atmosphere on the way down. That's not what's going on with some of the wet garbage on Haven 1. It's just going to stay with the station until the end of life for Haven 1, correct?
Yeah, so one of the key trade, back to simplicity, is we decided that Haven 1 would have only one docking port and would not require resupply, right?
Yep.
And so 3-year lifetime. And so that kind of led us to have a limit in mass and in volume where we could put all the consumable. And we ended up with 40 days. Okay, we think we can fit 40 days of consumables for the crew on Haven 1.
And that's like 40 crew days, right? Like 40 days that astronauts can be there.
Yeah, for 4 crew.
Right.
So 4 crew can be there for 40 days. And so we started thinking, is that enough? Is that worth it? And the conclusion was, yeah, if we have 4 expeditions, one every 6 to 9 months, each of them are 2 weeks, but there's 2 days to get there, 10 days on the station, 2 days to go back, 2 days to go back. We felt that was really worth it, and that allowed us to really simplify the design. So cargo resupply is expensive, right? These signals and so on are very expensive, so we can avoid that expense. And then the other side, you can have more complicated, I guess we don't do that, but disposal mechanism into orbit, which is probably not a good idea, or no one is doing, I think, without the orbiting capability of that trash can. So basically, it leaves you to either put them back on the Dragon and fly them back with the crew. But you'd be surprised, 10 days of consumables for 4 people, that's a lot of volume and a lot of mass. So it doesn't really fit in the Dragon. And we want to keep the Dragon return capability for experiment return and useful things.
Not the trash.
Not for trash or human waste. And so the design is that we have the corresponding volume or the adequate volume of these consumables, the wet consumables, into this trash can that then are sealed and exposed to the vacuum of space to make sure, obviously, they don't we don't have smells and we minimize all of that.
Good deal. Again, it's something we want to do here because we had this special opportunity. We were able to put out the video, put out the shorts, put out all of that information, and then see what questions people had, right? So I'm trying to take a couple of our questions there directly from common misconceptions that we saw in the comments and stuff like that. We don't often get that opportunity, so thank you for that. Let's move on to Haven 2, though. We're not getting too far ahead of ourselves when we talk about Haven 2, are we, Max?
No, great.
Okay, so Haven 1 is for the sort of keep it simple, let's get this going, existing technologies, learn our processes, learn our systems, get it up there and start getting some experience, right? Haven 2 is sort of the next step. So tell us, what's new, what's different, what's the big step that you go from Haven 1 to Haven 2? What does that get you?
So Haven 2 is not we're not building Haven 2 right now, right? It's our proposed design to the CLD competition, which is the competition that NASA is running to replace the ISS, and they are due to select a winner by mid next year. And so when we started to design Haven 2, right, what we actually propose to NASA might be changing as their requirements are still changing. So this is based on what we know today. And we took really 2 key requirements from our point of view. The first one is that we believe that it's critical for the United States and all of its partners to have a space station on orbit to replace the ISS as early as possible.
Right.
Not only making sure there's no gap, but also making sure there's an overlap. So our position is that, and that's changing, and we'll talk about some of the recent posts on X, I'm sure in a minute, but our position is that the US should really make sure that whoever is selected to replace the ISS can at least build a first module that has basic capability and have a crew visit it before destroying the ISS.
Right.
And so one of the elements of Haven 2 is the first module should be able to accommodate crew and should be on orbit before the end of 28, which is ahead of any of the plan of any of our competitor. And that's because we think it's really key to have an overlap between the first module and then the orbit of the ISS. That's our view of what's in the best interest of the country.
Right.
But then the other side is it needs to be low cost and it needs to grow into something that's more capable and more exciting than the ISS, and obviously better for business, in terms of iterating with people doing science, research, and manufacturing, but also enable capabilities like EVA and Earth observation and external payload. And so our view is that the architecture should allow to grow to a space station by, let's say, 2032, that is more capable than what we have on the ISS, but much lower cost and modern, but also that is better than anything that Tiangong is slated to be, right? Than China. So that's what Haven 2 kind of offers. It offers really the fastest start because it's a derivative of Haven 1. It has, the first module has 2 docking ports instead of 1. It's longer because it can launch on a Falcon Heavy with an extended fairing that SpaceX has been working on. It has more mass, it has more consumable, it has some improvement in life support, as I mentioned. But from a feasibility point of view, as NASA will need to evaluate, can VAS do this in this timeline? Can they do it, following our NASA standard? And can they do it within this budget? It will be, easy to believe, especially if you think that Haven 1 is on orbit, and this first module is just a derivative of it, launching on a more capable launch vehicle, and it's an upgrade of it. So that's kind of what drove the first module we can see there. And then we want to expand it. There's a lot of things that are different to the ISS. Each module is actually a dedicated space station itself. It has its own power, its own life support system. It can self-dock itself, its own avionics, communication. Of course, each of the module will have different outfitting. We might not have 4 sleeping berths in every single module. And some will have more science facilities and more laboratory. But the concept is we really have a common platform that we can quickly manufacture. And it's a lot faster, but also a lot lower cost because we don't have to have, if we have 9 modules, 9 different designs. We have one common platform that we slightly customize for each. And then in 2030, we plan to leverage the capability of Starship to launch a 7-meter module. Starship will be ready well before us, but it'll take us a time to upgrade all of this to do from 3.8 meter to 7 meter and all of the systems. And so our proposal is that the first time it will happen is in 2030. And then we reorganize all the module, and then we have the opportunity, if we want, to add 4 more modules there.
It really is a thing. Like I've asked this question of a few different people that I've talked to, satellite, deep space mission, that sort of stuff. And it's like, everything we send to space seems like it's bespoke, this one custom thing, and we're going to build this one really special probe and send it to Pluto, right? Why don't we just make a common bus and we're just going to send 5 of those to Pluto and 3 to Neptune? And here, like the fact that the space station modules are all the same basic design, and you've got a little bit of customization, you can outfit the inside a little bit different, but they all look the same. They all launch the same. They all weigh about the same. It just seems like such a good idea that we haven't been doing in space for a really long time. So I love the fact that you look at it and you can see that the modules all are sort of modules that match each other.
And the only way this really makes sense is if you are vertically integrated and you're doing low cost, because we are duplicating a lot of systems, right? We have a lot of CMGs, a lot of thrusters. We have all the flight computers and everything is, we have many of them. But for us, making more of that, because it's a design we've built in-house, so we have trusted partner. For propulsion, we use Impulse Space, the company of Tom Mueller. We have great partner in solar arrays and so on. But, it allows us to duplicate these because we have very low cost BOM, right? A bill of material. And I think if you do it in the traditional aerospace way, you might not be able to operate that way, right? Like you really should have the minimum amount of flight computer possible because maybe they are very, very expensive and very bespoke. The other advantage is the redundancy, is that if a module really goes wrong, of course we will try to do maintenance and repair it, but we also have the option to let it go and deorbit it. And that will not compromise the whole space station. So it will reduce capability, we'll have less power, we'll have we'll lose the facilities that are there, but the whole space station will still be, functional there. So in terms of, serviceability, and a lot of the work that's happening on the ISS is to repair and maintain and having spares. We have a lot of spares on this design because every module has spares of the other one, and we have full tolerance as well. And then we have the ability to lose a module if we have to.
Yeah, it makes a good. There's probably a balance here, right? You want redundancy, but you don't want waste. In space, it's good to have redundant systems. That doesn't mean you need to carry 80 flight computers, but each module being sort of a standalone can live on its own, can dock with other modules to make the station bigger itself. It seems like such a cool design that we just aren't used to seeing in space. I do want to go back to something you mentioned with the timing, though, because you were talking about, I think, Haven 2 and like a 2028 time frame and the importance of overlap between the existing International Space Station and having what's going to be next. There's been some dates bandied around about the International Space Station maybe doesn't need to last until 2030. Maybe it should come down in 2 years instead of 5 years. How does that affect VAST? Does that open an opportunity for you, or is that like, whoa, geez, we can't do that? How's that?
Are you
affect?
Referring to Elon Street without
Yes, I am.
mentioning it?
You got it. Everybody knows what I'm talking about, right?
Exactly. Let's not beat around the bush, as they say. So, firstly, what's happening right now is really fluid and, hard to comment specifically. But let's take a little step back first. So the idea that President Trump announced that we, the United States, we are going to significantly invest to make sure that we put humans on Mars. I mean, that's so exciting, right? Like, so exciting to everybody here at VAST as space people, but also think about VAST. What is VAST, right? Going back to the point I've said to you, we are a low-cost, rapid, soon to be proven crewed systems company. So that sounds like a good thing to be if the government is going to go all in and increase budget and get us to Mars, right? That's something that sounds pretty useful, assuming that, SpaceX will not be the only company there. There will be partners that can maybe build pieces of it and habitat. And that's something that we believe will be the case, but also we've heard Elon talk about the fact that they want to create a platform and they want, the pizza parlor on Mars, but that's obviously a joke, that there's an opportunity for partners to build on the platform. So that is, super exciting and amazing for VAST, and the budgets that will follow that. Related to the ISS specifically, just so the audience know exactly what the situation is, the Russian partners have agreed to maintain it till 28. So there's even a chance that it cannot be operated beyond 28. Right. The current US budget and congressional approval basically sees the ISS, being operational until 2030. With deorbit in it takes a while for the US deorbit vehicle from SpaceX to arrive and decommissioning it. So I believe at the end of 31 and maybe even in 32 is the current plan deorbit. So, for us, we think it's a good idea to have overlap in a platform. It's reasonable for all of the partners. But if the US wanted to get, more aggressive and deorbited earlier, I can tell you that's the best news ever for the Haven 1 business, because we will be the only basically non-Chinese space station that any space agency around the world will be able to buy seats to. We've announced our plan to sell seats to the ISS. There are these PAM missions, which are bringing private crew and other agencies for 2 weeks to the ISS. There's obviously a whole roster of 6-month mission that the US and its partner have slated till the end of 2030. If President Trump, as Elon recommended, deorbit the ISS earlier, that's not our recommendation, but that's not going to be bad for VAST, put it that way. So, so we'll be in a great position having built and having Haven 1 there. And maybe it will accelerate, the transition to commercial. We are obviously looking forward and have built a strategy around the budget to replace the ISS. And so we expect that to still exist. And one of the key reasons why we think it should be there is because if you are going to go to Mars and the Moon, right, or just Mars, you need a low Earth orbit destination to basically train your astronaut, to develop these life support systems and so on. And Starship sortie will eventually do some of that. But I think we still need it until cruise Starship is ready and we definitely need a destination. So we hope the Jared Isaacman, touching wood, that he will be confirmed, and obviously the congressional and the Congress and Senate will double down on the need for another new, more modern, lower cost, less money from the taxpayer, so that we can put more towards Mars destination.
Yep.
And we'll see what happens. So that's kind of where we are. So
You've hit the nail on the head there, I think. And if I will put a big red light that says opinion alert, like my opinion, we all know the space station, the International Space Station, costs a lot of money to operate, right? And if that money could go somewhere to help us develop new solutions, I would love to see that. Personally, as a person who's interested in space, I would hate to see the International Space Station go away and that funding just evaporate. And so having companies like VAST there that could actually benefit and are in a position to receive and make use of some of that money in an effective manner, that makes me more comfortable with the space station, the International Space Station, going away. I feel like I have to specify which space station I'm talking about, which is a good problem to have. I don't want that money to just evaporate and the space station to evaporate and it not to end up in the hands of folks that are doing really cool stuff with it. That's why Max is on the screen, right? So turn off the opinion light now.
Yeah, and back to the point, our recommendation to ensure a smooth transition is you accelerate buying the initial module from the CLD competitors, and you really make sure we have a new module that is NASA certified, that can host astronaut, Haven 2 Module 1 or some of our competitors' module as soon as possible. And then once you've proven that, you deorbit the ISS. That's our recommended approach, so we make sure there is no gap. But if the US government wants to be more aggressive, wants to take more risk, especially to free up that budget to go towards Mars and towards an alternative, a new CLD, a new commercial LEO destination, that wasn't our recommendation, but sure, great, let's do it. Let's go faster.
Good deal. Let's check in with Dee real quick. Dee, do we have another question from the audience per VAST-2 or future plans here for Max?
Yeah, we sure do. So Trey9 was wondering if we could see multiple Haven 2 stations or multiple artificial gravity space stations. I know you said like each section can function on their own, but would there be a world where there are multiple hubs up there that are all their own Haven 2s?
And it's a question of the market, right? Right now, our view is that a space station company that wins the NASA competition should be able to be profitable with the current market. So the market is NASA, not as 100% of your revenue, right? And don't forget that NASA wants to replace the ISS. One of the key reasons is to reduce the budget. So NASA as not the only customer, right, of us. Then we have international space agencies that are buying seats and doing science on space station. And then we have private individual, which is 10-20% maybe of the revenue. It's not zero, as you know. There's many missions that have been sold, and really amazing people that are doing it not for tourism but to further the state of the art of space exploration or make life better on Earth. But that's the existing market for space station today. So the key, we believe, is that NASA should pick a company that, with that market, has a low enough cost and is agile and is iterative enough so that they can be around with just that market. And then the next step is, will we unlock in-space manufacturing, right? Creating drugs that cannot be made on Earth, that, a crew goes on a Dragon to harvest, and then you bring, maybe 100 kilograms of the drug material from the space station on Earth, and you sell that, once a year for a few billions of dollars in a drug that cure the disease and that can only be made in space. If that happens, right, that's the holy grail. I don't know if it'll take 5 years, 10 years. I think it will eventually happen, and that's only one of the applications of microgravity manufacturing. But if that happens, then we will be making space stations as factories completely unrelated to space agencies and NASA, and they will be profitable paying for themselves. So in that case, when that happens, I think you could see not an unlimited number of Haven 2s or space station, but certainly it won't be constrained on the taxpayer budget of NASA or other agencies around the world.
Right.
Before that, there's also a step where you might see the Middle East or you might see maybe Europe, the Middle East seems more likely, wanting to have their own space station. And that will only be true if it's low cost enough. And so, as VAS succeed at building these modules at an unprecedented low cost and speed, you might see some of these nations, thinking, okay, I'll have a small space station that's dedicated to me. And so the Haven 2 architecture allows that, right? They can buy many modules, or they can just buy one. Right now, we are just assuming that all of the international partners and new emerging countries are sort of trying to make Haven 2 happen, right? They're trying to keep this partnership and stay together with NASA in the United States. But the architecture supports other mode or duplicate, as you mentioned.
Makes sense. And D, I think we got one more, right?
Yeah, we've had lots.
And sorry, to finish on that one.
Of course.
Our goal is to have more people living in space than on Earth, right? That's our goal. Not because there'll be less people on Earth. There should also be more people on Earth. But back to that long-term goal. Yeah, I hope there are thousands of Haven 88 space station, or whatever we call it. So
nice.
That's definitely where we want the world to go.
Awesome. So we've had lots of questions about your artificial gravity space station that's in the roadmap. And one of those that a lot of people have been asking is, how is docking going to work with that? Of course, you're spinning end over end. So does the spinning have to stop for the spacecraft to dock, or how will that work?
Yeah, we thought about it.
Okay, good. You have music ready and everything.
Yeah, I think most people know the answer through science fiction. It's basically spin docking. There's really only two options, right?
Yep.
You spin dock. You've all seen. I think it's in 2001. It's definitely in Interstellar somehow.
Yep.
And so you spin the space station and the visiting vehicle at the same rate, and you dock, and that would be pretty incredible and amazing when we get to do that. The other option, which we could do for early experimental station, but not long term, which would be to stop the spinning and respin. But obviously, the amount of propellant needed for that is,
right.
It's really not doable more than once or twice in the life of the station. So spin docking is what we hope we will demonstrate and achieve when we get there.
Good deal. That question popped up a lot because we see the renders of the rotating station. People are like, oh, that's not going to work. How are you going to dock to it? Like, you haven't thought of that. Do y'all not watch science fiction? Like, it's becoming science fact these days. Max, we are running short on time. We had you for just about an hour here, but there was one more big question that's almost more of a philosophical question, right? You talk about wanting to have more and more people living and working in space, right? And as we move out there, we were very happy to see in Haven 1 a window, so that you can be there on the station and you don't just have to look out the Dragon window or whatever brought you there. You've got this big, beautiful window that you can look out to see the Earth or stars or whatever. How does that sort of fit with Haven? Is Haven, in the idea of making space stations, do they need windows? Why don't you just put big monitors everywhere? How does that sort of balance humanity living in space?
Monitors everywhere would be pretty cool, but they're pretty massive, power intensive. So windows are great, and obviously are the real deal, close to, I guess, an EVA with a helmet is the real deal. You don't want to go any further than that, I guess. I think connecting with the Earth, if you talk to any astronaut that has gone to space, the connection to the Earth, realizing how special it is, or how insane it is that we are so small, lost in the darkness of space, and how far everything is. When I hear our lead astronaut, Drew Feustel, talking last week, we were in Japan on an interview, it was super inspiring, and it's obviously a key importance of sending people to space and gathering this overview effect. So I hope and I believe all of our space stations will have windows, even the ones that are just factories for pharma that we send people. Let's keep some windows in there for sure.
Good deal. It really is. It's like we've done so much sort of working in space, but it's always the astronauts go up there to do the job, and they have these little teeny tiny windows, and then we get the cupola on the International Space Station, and it's sort of part of us being there. We want to be there. We want to live. We want to work. We want more and more people to have reason to be in space. And in order to do that, we need places for them to go. So having destinations out there that VAST is putting together, habitable space in whatever orbit it ends up in, starting off here in low Earth orbit and going wherever they can get it to go, right? Let's see. We walked through your entire factory. We looked at so many different things, all the different solutions that have to be come up with. I got strapped into an inflating bed. If y'all don't know what I'm talking about, make sure you watch the actual factory tour. We had one of your astronauts there that are helping you design solutions.
Yeah.
Strapped me into the bed. If y'all haven't seen that tour, please make sure you check out the entire video. It's over 70 minutes long. But Max, while we were walking, look, I'm in a window. I'm in the cupola. While we were going through all of that, it seemed like there was so much to talk about. Was there anything that we didn't cover there? Anything that you think is really cool that VAST is doing that we haven't shared or we didn't really dive into? Maybe people don't know to ask the question.
No, I mean, I hope your audience will give a big shout out to our amazing engineering team and everybody that support them. The whole culture at VAST is a culture of responsible engineers, so we're engineering centric, and our responsible engineers, all the responsibility of human life, right? Their system, whether Joe that was the RE, that's what we call it, on the window, is going to all the responsibility that the people in there are alive and it's safe, right, all the way through. And so we have this culture with these amazing responsible engineers. They have teams, and then we have a lot of support function, right, whether it's facilities or quality or, so many of us, right, finance, whatever you call it, IT and so on. And so that's sort of how we are with all these groups that are supporting them in doing their job. I'm a support function, as well. That's the way I look at it, in supporting that teams of RE. So I guess the only thing, give them a shout out, because without them, none of, I get to show off all that stuff, but it's got nothing to do with me to some extent. So really excited to show their work.
It's made by the team there, and y'all can see that, like when we did the tour, when you walked us around the factory and shared your wealth of knowledge with what's going on with this, you could see people in the background, machines running, all sorts of things going on. The machines don't run themselves. So anyways, that is going to get us here towards the end of the show. I think VAST hiring, aren't you, Max? You looking for people to join the team?
It's actually, it's toward the end of our, hiring rampage, you could call it. So our goal is to cap out at 1,000 people. We are at 750, I think, right now, and we want to cap out at 1,000 people or 999 for Haven 1 and flying Haven 1.
Sure.
And then we'll grow again once we win the NASA competition CLD. So I think we'll reach that number by August. So there's only a few more months to get in, and then after that there'll be another growth spurt. So if you're an engineer or anyone that can help our engineering team, please consider applying. It's on vastspace.com.
Yeah, good deal. We'll put the link in the chat over there if you're interested in learning more. vastspace.com is the URL. Of course, make sure you don't miss the entire tour. You might have been like, oh, what is this, a 70-minute video? I don't have that attention span. If you don't watch the whole video, you're missing out, because VAST is doing really cool stuff. Max, thank you so much for spending your afternoon here with us today.
Great, thank you. And I'm sure many of the people at VAST were watching too, so great. We did a meeting as well, so thank you.
Excellent. Well, folks, that is going to bring us to the end of our live interview. It's Max Haot, CEO of VAST. They're making space stations, not making space station renders, not making pretty pictures of space stations, actually working a plan to get hardware into space so you can become a space station company. Max, thank you so much for the time.
Cool, thanks, Des. Thanks, John.
All right. Hey, either way, I answer to both. Folks, again, make sure you check out the full tour, and we've got a busy week coming up here. Y'all know what that means. Bigger rockets launching so that bigger space stations can be launched one day. Very interesting things in the Starship. world this week. So stay tuned. We've got lots of live coverage. We've got videos coming out. As always, we appreciate y'all hanging out with us. Appreciate you watching the videos, supporting, asking good questions. Y'all know I read the comments. So if you've got a really good question about something going on at VAST, I'll probably try to answer it for you. Just put them down in the comments below the video. For now, that's going to end our live interview. Massive thanks to the VAST team for working with us and sharing all of what's going on over there. For now, appreciate you watching, and we will see you nerds later.
And here we go. We have liftoff.
Propulsion continues to be normal.
R68 chamber pressure looks good.
Rolling up. Roger, roll, Atlantic. Water towers, fly! Yes!
Tango down to nominal.
Fighting downside FD off.
Bring in FD off.
Off. It's orange! Orange 45! Oh my god! Oh my god! Décollage! Look at this! Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You good? We don't need any more of these.